So for our second example, we have the triangle here given where we're going to say that angle A is 40 degrees and angle C is 22.5, and we need to use that to solve the given triangle. So here we're given a side length and the two angles adjacent to it. That is an ASA, oblique triangle. ASA triangle of any stripe for that matter. So if you want to solve this, I'd say we start in the same way. We're actually given essentially the same pieces of information, just not in quite the same arrangement. But, well, let's find that angle measurement. We have A plus B plus C equals 180 degrees. But we have A and C. 40 plus B plus 22.5 is equal to 180. So subtract over 40, subtract over 22.5, and we'll get that the angle B is equal to the not very pretty measurement of 117.5 degrees. And then from here, it's entirely a matter of some creativity with the law of sines. We have that A over sine of A equals C over sine of C, which, following some rearrangement, says that A is equal to C sine of A over sine of C. Plug in our values. That's 12 times sine of 40 over sine of 117.5, which, pulling that in, approximating for the fact that those aren't nice angles, gives us a measurement that A is equal to 8.7 unitless measurements approximately. And very similarly, if you want to get B, we have B sine of B equals B over sine of B equals C over sine of C, or B is equal to C sine B over sine C. Plug in our numbers, 12, 22.5, 17.5, 117.5, excuse me, and we'll get B is approximately 5.2 unitless measurements. It doesn't really matter what that number is in terms of like meters, centimeters, inches, miles, what have you. We know what it is roughly. So these are our examples for how we handle things if we have two angles and one side, but what if we have two sides and one angle? Does it work in the same way? And also, do we call it what I think we might call it? Well, we'll see that the answers to both of those questions are sometimes and get your head out of the gutter. No, but we'll see that soon.